Hello my dear students, this is Akash SD and welcome to the NEET Physics classes. Hope so, doing really great. So students, in this video we are going to learn about the straight line motion basics, like what is the mechanics, how many parts are there, distance, displacement, average speed, average velocity and questions. Okay, so all these things we are going to cover in this video. Let's start the video and let's learn all these things. So students, you can see very well the topic is the mechanics. So what is the mechanics? You can see very well. It is a branch of physics which deals with the study of motion of an object. What it deals? Study of motion of an object. Okay. After that, you can see it can be broadly divided into three main branches. What are the names are there? You can see very well. Statics, kinematics, and kinetics. Okay, and now if we talk about here what is the statics, so can you see very well, it is a branch of mechanics which deals with the study of permanent or instantaneous rest of an object. Okay, and see here, very important, in this state resultant force acting on the object will be zero. That means all the forces will be balanced. Okay, so students, here we have seen the mechanics into three categories: statics, kinematics and kinetics, and now we are seeing here the statics, and here we have deal when the object in a rest situation, maybe permanent or maybe instantaneous rest. And remember that in a rest situation the net force acting on the object will be zero, or we can tell all the forces will be balanced. Okay students, so now after that we are going to see the kinematics, that is the most important for the straight line motion. So see here, kinematics. So see here, it is a branch of mechanics which deals with the study of motion of an object without considering the factor, that means force, which causes motion. Okay, and you can see very well it is also called a study of a pure motion of an object. Okay, so in straight line motion, this straight line motion chapter, the motion in plane chapter, this comes under the this kinematics. Here we will study speed, velocity, acceleration. But why this motion is happening? That means the force is responsible for the motion. That thing we will not consider. That we will consider in a loss of motion chapter. Okay, so this is the kinematics. Second one, if we talk about here, the name is the kinetics or the dynamics. So say here, it is a branch of mechanics which deals with the study of motion of an object with considering the factor, that means force, which causes motion. So students, remember that here this statics, kinematics and this dynamics, these three branches are there. From here the question will not come, but for our basic understanding, now what is the basic understanding of this subject, for that only we have learned that. Okay, now after that we'll go to our basics. From there the question and all used to form, and here you can see very well we are going to study about the rest and motion, because we should know now all this basics. So see here, the rest. So under the rest you can see very well, we know also if the position of an object does not change with respect to its surrounding with the passage of time, it is said to be at rest. Okay, that means position should not change with respect to time and with respect to the surrounding. Okay, great. Similarly, if we talk about here the motion, see, if the position of an object is continuously changing with respect to its surrounding with the passage of time, it is said to be in a motion. Okay, so just simply basic definition is there, kindly remember this. Is it rest and motion? Next one, remember that here, very important thing. See, rest and motion are relative but never absolute. Again I am telling, this rest and motion terms are relative terms. Okay, see here, it means an object can be at rest with respect to one observer, but the same object can be in motion with respect to another observer. Okay, and let's see first example. What is the example is there? See, a person sitting in his house is at rest with respect to earth, but it is in motion, it is in motion with respect to moon. Okay, so remember that here this rest and motion are relative term, students. Okay, like for the example, if in case you are sitting in car with your friend, okay, and your third friend is watching you, so what will happen that here, you are at rest with respect to a friend who is sitting in car with you, but you are in a motion with respect to a friend who is standing on the road and seeing you are moving in a car. Okay, so you can be at rest also, you can be in a motion also, depending upon who is the observer. Remember that here. Okay, great. Now students, next one, the point object, because full physics revolves around the point object. Any kind of object is there now, most of the time we will consider as a point object. Even later you will study center of mass concept also, that will also convert one extended object to the point object. Okay, so we are going to learn in which situation an object can be considered as a point object. Okay, so can you see here under the point object, an object is considered as a point object if the size of the object, is much smaller than the distance traveled by the object, okay, in the reasonable duration of time. You can see very well, what is the keyword is there, the size of an object is much smaller than the distance traveled by the object in the reasonable duration of time. Okay, and if we talk about here the example, let's see here, if a bus of length 8 meter travels 5 kilometer, then it is considered as the point object, because you can see very well the length is too much, 5 kilometer. So with respect to 5 kilometer, this 8 meter is the very small. Okay, so in this situation we can consider this bus is the point object. But let's take for example, if this bus is traveling just 2 meter, 3 meter, then we cannot consider as a point object. Okay, similarly if we talk about the earth, earth is the very large, but if you see the earth distance traveled by the earth during one revolution, so that distance is very large during the revolution compared to the shape and size of the earth. So in this situation even earth can be also considered as a point object. Very simple concept is that the distance traveled by the object should be much more larger than the shape and size of the object, especially the size. Okay, remember that. Great. Now students, you are going to see the next topic, distance and displacement. Very basic topic, we will finish it quickly. So see, first one, distance. It is the actual path length, covered by an object. Okay, and you know very well, distance is a scalar quantity and its SI unit is a meter. Now we know very well. Great. If we talk about here the displacement, can you see here? Very important. It is the shortest distance between initial and final position of an object. Okay, and displacement is a vector quantity and its SI unit is a meter. So as distance is scalar, as of now this distance will be always positive. I am not telling that all the scalar quantities are always positive, but some scalar quantities can be always positive also. Okay, so distance is a kind of scalar quantity that will be always positive. If we talk about here this displacement is a vector quantity, so it can be positive also, it can be negative also, or it can be zero also. Okay, so kindly see very well this distance and displacement. Now students, if we take here one example, we are going to see here. Let's take for example, the first example I have taken here. In this, if object travels in a straight line, what is this? If object travels in a straight line, very important, straight line without changing direction. What is this? Without changing direction. Okay, so let's take for example, if I take here, let's take for example this one here. This I have taken one line. Okay, and here what is this here, students? One object is there moving from A to B, moving from how much? A to B. And let's take for example, this is 5 meter. Now just moving A to B. Now so in this situation, when it is moving A to B, students, so in this situation, can you tell me what is the distance? Distance means actual path length. That means actual path length how much here? 5 meter. Okay, and if we talk about here the displacement, what I am talking about here, if I am talking about here the displacement, so when it is traveling in a straight line without changing direction, then what will be there? The displacement will be also how much here? 5 meter. Okay, so in this situation, students, what will happen right here? In this situation, we can tell very well this distance will be equal to displacement. Okay, this distance will be equal to displacement. Okay, even the displacement can be vector. Okay, so we'll, to be safer side, we will write here the magnitude. Okay, and this is the equation 1. What we have seen here, can you see very well? When the object is traveling in a straight line without changing direction, then only what will be there? Distance will be equal to the displacement. Okay, And if we talk about here the second one, here what is happening? Let's take, I am taking one more situation. Let's take here, first object is traveling in this direction. Let's take maybe east direction now from A to B. Okay, some, let's take for example 3 meter. And after that, let's take B to C in the north direction 4 meter. Okay, so you can see very well here, the direction has changed. No? Direction has changed here. So in this situation, students, here, if the direction is changing, okay, if direction is changing, maybe it is moving in a straight line then changing, or maybe it is in a circular path continuously changing. So in this situation, what will happen that here, if I write here the distance. So students, what is the distance? Distance means actual path length. So you can see very well, this is the 3 meter, this is 4 meter, total how much? 3 plus 4, 7 meter, is it? And after that, if I talk about here the displacement, no? Displacement. So students, here the displacement is given by, if I write here the displacement, the shortest distance. So I can write here this dotted line. No? This dotted line is there. No? So from the Pythagoras theorem, you know very well, this is the 90 degree anyhow. So if you apply the Pythagoras theorem, square root of 3 square plus 4 square, that means base square plus perpendicular square is square root of. So what it will come here? 5 meter. So here you can see very well the displacement, how much here? 5 meter. So students, if we compare both of them, here you can see very well what we can tell here. See, this distance is greater than the displacement, correct? So when the direction is changing, then all the time distance will be greater than the displacement. And let's make it here equation 2. Okay, make it here equation 2. So students, after that, if I write here, no, see, if I write equation 1 and 2 both I'll combine. So if equation 1 and 2 both I can combine, I can write here, students, here, this distance is always greater than or equal to displacement. What is this? Remember that here, distance is always greater than or equal to displacement. Okay, this general term is there, have to remember that here. If in case I take here the ratio, let's take for example distance by displacement ratio. So what it will come here, students? Generally it will be always greater than or equal to 1. Distance by displacement ratio greater than or equal to 1. Okay, and if in case we are taking here the reverse ratio to be the safer side. Okay, so that you should remember that here. If in case I write here the displacement by distance ratio, okay, generally, so it will be how much here? Less than or equal to 1. All these things you have to remember that kindly, because question used to come from here. Okay, great. Now students, after that, after distance and displacement, we are going to move for this one here, average speed and average velocity. Basic term, but okay, we will see that here. So what is the average speed? We know very well, see. It is the rate of distance traveled by an object in any direction. Why any direction? Because we know very well speed is a scalar quantity, direction does not matter. Okay, so if in case I want to write here the average speed, so average speed, what is the formula is this? We know very well, total distance traveled, no? Total distance traveled by total time taken. Okay, average. And remember that here, whenever we are writing total distance traveled by total time taken, there is the one speed value will come, and that is the what? That is always one constant value. Average speed is one kind of a constant speed, hypothetical constant speed. Okay, so remember that here, average speed means hypothetically I am telling that here, not really. Average speed means hypothetically constant speed, or even we can tell here uniform speed. Okay, uniform speed, is it? So remember that here, average speed is the total distance traveled by total time taken. It is a hypothetically constant speed, or we can tell uniform speed. Okay, similarly, note what are the important points are there. Can you see very well? Average speed is a scalar quantity and it will be always positive. That will see that here. SI unit is meter per second for the average speed. And if we talk about here the practical unit, now one more unit is there, students. Practical unit, tell me please, what is the practical unit? This practical unit of the speed is given by kilometer per hour. What is the unit here, students? Kilometer per hour. And after that you have to remember that here, one more basic. If in case we have x kilometer per hour, then what we have to do here? We have to just multiply with the 5 by 18 and we'll get a meter per second. X kilometer per hour means x into 5 by 18 meter per second. Okay, and if in case we have y meter per second, then what will be there? It will be y into 18 by 5 kilometer per hour. Okay, so this conversion you have to remember that. Maybe we have to convert kilometer per hour to meter per second, or maybe meter per second to kilometer per hour. Okay, and dimensional formula you know very well. It is the LT minus 1, always write in a big bracket, and you know very well speed is always positive, as I have told you very well. So this is the average speed and it's the important points. Okay students, great. Now we are going to see here in a average velocity. Now, so kindly see here. It is the rate of displacement traveled by an object in a specific direction. A specific direction means it is a vector quantity. Now that's why direction matters here. And if we talk about here, let's take for example here one object is this. Now it is moving in a straight line. Straight line or any other direction. Okay, just for the general situation I have taken here. And let's take this is the origin. Is it? So let's take what is here. Here I can write here point A, and here I am writing here point B. Okay. And let's take object is moving from A to B. Now, this length how much here? Let's take this length is x1, and this length how much is there? Let's take this length is x2. Now, and the time, let's take at this one, time is t equal to t1, and at this point, time is t equal to t2. So students, when it is traveling from A to B, then average velocity, very, very important. It is given by what? Total displacement by total time taken. What is this? Total displacement by students, total time taken, or we can write here just a total time. Okay. So what will happen right here? When it is moving from A to B, how much displacement is there? See, this is x1, this is x2. So students, you can tell very well, this is x2 minus x1. What is this? X2 minus x1. So that is the displacement x2 minus x1. Time taken, that means time interval between the 2 points. So here time is t equal to t1, here time is t equal to t2. That means how much time interval? t2 minus t1. Is it? So students, please remember that here. This average velocity, very, very important formula. This average velocity is given by delta x, that means x2 minus x1, by delta t, that means t2 minus t1 here. Okay. And if in case we are using here in a physics and all that, so we can use directly this formula. What is the formula? Like this we used to write here. X at t equal to t2 minus position at t equal to t1 by t2 minus t1. Okay, like this we used to write here in a physics. And if in case the object is traveling in a straight line without changing direction, then what will happen right here? As distance and displacement both is same, so average speed and average velocity will be also same here. And the same formula we can use when the object is traveling in a straight line without changing the direction. Okay, and see here, average velocity is the which quantity? Vector quantity, we know very well. SI unit is meter per second. Practical unit, as I have told you very well, kilometer per hour and all that. Okay. Dimensional formula, same students, LT minus 1. And the most important, see here, average velocity can be positive, negative, or you can see here, 0. Is it? Speed is always positive. But average velocity can be positive also, negative also, or 0 also. Kindly remember that very well. So students, here also, under the example, as I have proved what? As I have proved you students here, like a distance is always greater than or equal to displacement. Correct? We have done previous example. Is it? So what will happen right here? If in case both the sides I divide by the time. No? So what we can write here? We can write here, students, this distance by time is greater than or equal to displacement by time. No? Displacement by time. Is it? And what is the distance by time, students here? That is the average speed. Okay. So average speed can be greater than or equal to what is this? Average velocity. Okay. This thing you have to remember that here. And what I have told you, students, that also you know very well. If the object is traveling in a straight line without changing direction, then what will be there? In that situation, what will be this? This average speed will be equal to average velocity. In which situation? When object is moving in a straight line without changing direction. Okay, straight line motion but no change of direction. In that situation, what will be this? Both of them will be equal. Have to remember that, very, very important. Okay, and otherwise, if in case the direction is changing, then always what will be this? This average speed will be greater than the average velocity. And as I have told you, velocity can be negative also. So see this magnitude I am writing. this magnitude, okay, and here also this magnitude is there. And here what is happened that here, students, here the direction is changing. Now if direction changing, if direction is changing, okay, if direction is changing, please remember that all these things question used to come. If they ask the ratio of average speed by average velocity, it will be greater than or equal to 1. If they ask the ratio of average velocity by average speed, it will be less than or equal to 1. Again, I am telling that average speed by average velocity greater than or equal to 1. Done. Next one, average velocity by average speed less than or equal to 1. Okay. Even I can write here, see, remember that here. If I am writing here average velocity by average speed, okay. So what we know, that will be less than or equal to 1. And if they ask average speed by average velocity, then what will be this? This will be greater than or equal to 1. Have to remember that here. Okay, directly question used to come. That's why again I have written for you. Okay. Now students, after that we'll see here this question, important question. Now for the NEET and JEE, see, very easy question. An insect crawls a distance of 4 meters along north in 10 seconds and then a distance of 3 meters along east in 5 seconds. The average velocity of the insect is how much? So students, to deal with this kind of situation, first you should know the direction convention. So in physics, what direction convention we take here? We take here, students, this is east, this is west, this is north, this is south. Now east, west, north, south, like this we take. Okay. Now we'll draw here the situation. 4 meters along north direction. Okay. So let me draw here. This is the 4 meters. Now along which direction? It started from here. It started from here. This is the starting point here. Now initial point I. 4 meters along north direction. How much time it has taken here? And here it has taken here time. T1 is the 10 seconds. Now because maximum questions can be solved when we can draw it. Okay. After that, 3 meters along east in 5 seconds. So 3 meters along east, like this here. Now this is the 3 meters along east in how much second? T2 is the 5 seconds, like this. Okay. And what they are asking? Average velocity. Again I am telling, this is the north, then this is the east. So now what is the average velocity, students? You know the displacement by time. Okay. So displacement means what? Like this. Like this. And you can see very well, it is the one right angle triangle. If you use here the Pythagoras theorem, what this distance will come? Initial to final distance, it will come here 5 meters. Is it? So students, if I write here the average velocity, what I am writing here? Average velocity means total displacement. Displacement how much? By the Pythagoras theorem, 5 meters. And total time taken how much here, students? See, this is the 10 seconds, this is 5 seconds. Total 10 plus 5, 15. No? So 10 plus 5 will write here, 5 by 15. And what this will come here? 1 by 3. You need to have to be very, very careful. Distance means the traveling is given here in a meter, time is given in a second, that means 1 by 3 meter per second. Okay. And if in case, students, if they ask here the average speed, what they ask here? They ask here the average speed, for example. Then what will be this? Distance by time taken. How much distance? 4 plus 3 actual path length, 7 by 15. Okay. So we can write here anyhow the 7 by 15 meter per second. Now, and you can see very well, students, as here the direction is changing. Here the direction is changing. So you can see very well this average speed, that means 7 by 15 is greater than the average velocity, that means 1 by 3 meter per second. Okay. Can you see very well how we have done this? Now, very easy question based upon the distance, displacement, average speed, average velocity. And now this question, this kind of question also used to come sometimes. We'll see here. Now, so the question is, see, a 150-meter long train is moving with a uniform speed of 45 km per hour. I told you, remember, like average speed is just like a hypothetically uniform speed or constant speed. Okay. And see, the time taken by the train to cross a bridge of length 850 meter is how much? Okay. So here what will be there? We will write here one by one. The length of the train is given here how much here? It is given here 150 meter. After that, the length of the bridge, that means B, is given here how much here? 850 meter. Okay. And after that, the speed of the train, uniform speed, how much is given here? 45 km per hour. But you can see here, all the options are here in a what unit. So students, here we have to write here 45 into kilometer per hour to meter per second. What we have to do? We have to just multiply with the 5 by 18, then it will come here what, students? It will come here meter per second. Okay, then after that we can simplify this. Can you see 3 6 ja 18, and here 3 1 ja 3, 3 5 ja 15, is it? Then after that even we can write here, see 3 2 ja 6 and 3 5 ja 15. How much is coming here, students? Here 25 by 2 meter per second. Okay. So we have done very well now. 3 6 ja 18, because calculation mistake should not be there. 3 6 ja 18, 3 1 ja 3, 3 5 ja 15. Okay. Then after that what we have done, 3 2 ja 6, 3 5 ja 15. Even directly we can cancel by the 9 also, no problem. Okay, so anyhow we have got 25 by 2. Now remember that one more thing, students. Let's take for example, this is the bridge. Now this is the bridge is there. Okay. And what is this? The students, one train is there. Now length of this bridge is how much here? Length of this bridge is B. And one train is there. This train is coming. This train is coming, and this train is going to cross a bridge. So what will happen, that is, students? If the length is going to cross a bridge, you know total how much distance it has to travel. First, this train has to cross the. First, this train has to travel the distance of bridge. After that also it will be on the bridge. Then again it has to travel the distance that is equal to its length. Okay, so students, the total length traveled by the total distance traveled by the train to cross the bridge will be length of train plus length of bridge. That means how much? L plus B. Okay, so in this situation what will happen, that here the time taken will be given by what? You know, speed equal to distance by time. Speed equal to distance by time. So time equal to how much here, students? Here distance by speed. Distance by speed, that means L plus B by V. Distance by speed. Okay, so here, students, we can write here L plus B, how much is given here? See, 150 plus 850, that means 1000. 1000, is it? And here 25 by 2 is coming. No? 25 by 2, that means it will go here into. So students, when you will simplify this here, you can see very well. 1000 by 25 means it will come here the 40 into 2. And 40 into 2, how much are the students here? We can write here very easily. It is going to come here the 80 second. No? So correct option is what? Option C. Can you see very well how we have done this very important question? Total distance traveled means length of bridge plus length of train. That means L plus B. Then only train will cross the bridge. So students, I hope so this video you have understood very well. Keep studying, keep growing.